Hello, everyone. Thank you so much for tuning in today. And I'd like to thank Product School for inviting me to give this talk. I'm super excited to be here. Today, I'm going to spend a little bit of time talking about product management and give you my take on how it applies to AI and ML specific products. Before we do that, a little bit about me. I was born and raised in Iran, in the capital city of Tehran. I moved over to Canada in the year 2008, and I lived in Toronto for 6 years. And that's also where I went to school for computer engineering. After school, I moved over to Seattle to work for Microsoft, and I spent a good chunk of my career there in their cloud and AI division, particularly their cloud computing offering called Azure. And as of very recently, I switched over to work for Facebook. A little bit more about me. I'm a tech enthusiast. I like to learn things whenever I get a chance. I'd like to pick up a book or two, time permitting. I'm a big foodie. I like to explore the food scene in every city that I go to. And I'm an aspiring traveler. I'd like to see as much of the world as I can, although COVID has put a little bit of a halt on that plan, and as I'm sure for the rest of you folks as well. And I try to take Instagram-worthy photos, but I very rarely post them. And my partner tends to think I try too hard to look cool in those photos, but I only do that sometimes. Now, moving on to more serious parts of this presentation, just setting some agenda, I'd like to begin by saying why you should even care about AI. So this is where I'll be making the case for AI. And then I'm going to transition into what your role is going to look like as an AI PM. And just a little disclaimer on that, I'm not going to go super deep into the AI side of things. There are a lot of great talks, some at Product School, that are specifically for that, and they go very deep into the AI components of it. I'm going to keep that high level and then focus more on the PM side of things. And I'm going to do it in four basically subsections. So I'm going to make the case that you need to have an understanding of the field. You need to understand what set of problems are applicable to AI, and more like where AI is applicable to those problems. Then I'm going to talk about how to leverage your team when making these AI products. And finally, putting all this together, I'm going to talk about how to manage an AI product cycle. And I will conclude by talking about some of the challenges that AI introduces, and that'll be that. So without further ado, let's get started. So why should you care about AI? So my first reason is that AI is becoming very commonplace, and all sorts of industries and all sorts of businesses are investing very heavily on it. This Forbes article, for instance, is stating that 80% of enterprises are investing in AI today. And the thing to pay attention to over there is that it's not talking about a specific tech or tech industry in particular. So it's becoming very ubiquitous, and the process is transforming a lot of things. Second, it's a growing field. Even though it's been around since the 70s and it went through a little bit of a lull period, as of late, at least past 5 to 10 years, it's been growing at double digits, and it's expected to grow at the same rate in the future. So in the 2020 alone, it's expected to grow 54% in the United States, reaching 22.6 billion US dollars in market size. On the flip side of it, it is also a major source of socioeconomic changes, which could also mean major source of socioeconomic disruption. So take it from job loss to what truth is going to look like when you can deep fake a video. All of these things are challenges where society needs to adapt to this new world that is powered by AI to an extent. And finally, there is heavy cost associated with falling back in this field. This is both at an individual level. So suppose somebody right now didn't know what the internet is. I would wager that in the next decade or two, AI is going to be pretty much in the same position as well. It's also on a societal level. So just like any other tool, AI is a tool that it is up to whoever's using it to determine for what purpose they're going to use it and what frameworks they're going to put around their usage of that tool. And I'm going to argue that as a society, we're not going to be able to control or influence that conversation around fair use of AI and ethical use of AI unless we're willing to invest in it and learn about it. But a figure that got me the most was this one that I found in a McKinsey report that stated it is anticipated that by year 2030, AI and AI-related products are expected to add $13 trillion to the global economy. Just to put that into perspective, that's the equivalent of the GDP of China. That's the equivalent of adding another China to the world in terms of its economic output in just one decade. And this is what was my reaction pretty much when I heard that figure. And if it is yours as well, you should keep listening. So I'm sold. What's next? What should I do as a PM who wants to work in this field? So as I said before, your job as a PM is to roughly understand what AI and ML is as a field of technology, then know how and where to apply it. And then you also need to know how to use your team, and we'll get to that in a bit as to why. And putting all that together, then you need to know how to successfully manage a product lifecycle and release a good product that is powered by AI. So let's get started. What is AI? This is pretty much a paragraph that I copy pasted from Wikipedia. The gist of it has to do with machine intelligence as contrasted by natural intelligence. So traditionally, intelligence was a domain dominated by humans, or at least by nature. Whereas right now, with the advent of AI, we're coming to a point where we can replicate at least things that look like intelligence in machines or pieces of code. So what I like about this definition in particular is that it references the study, or rather the design of intelligent quote unquote agents that can perceive their environment and take certain actions or make certain predictions. Doing similar thing, and what ML is, it says it's a study of algorithms that improve automatically through experience or data. To talk about how it's a subset of our artificial intelligence, in my humble opinion, it's more a pathway to artificial intelligence. It's one of the ways that you can build artificial intelligence. It has to do with building these mathematical models that, once trained via some data, they have the ability to either make some prediction or some sort of decision without explicitly being programmed. So, doing a bit of a deeper look on this, what does this look like? So there are 3 stages of AI that, in the industry, when you do some reading, you come across these. There's one thing that is known as artificial narrow intelligence. That's the stage that we're in right now. And I'd like to think of it as the job of designing perceptive agents. So think about part of your brain that is really good at detecting different objects. So suppose you're shown a picture of a cat. It doesn't matter if you're shown that picture front, back, sideways, in all sorts of these combinations, your brain still has the power to detect that what you're looking at is a cat. So artificial narrow intelligence is the job of creating this type of intelligence. Now, if you were to fast forward that, the next aspiration would be to create something that functions like the human brain, and that's artificial general intelligence. So if we get there, at that point, we will be able to synthetically create what looks like or acts like a human brain. And here, the way it's different than machine intelligence today is that your brain is a lot more nuanced and it's a lot more complex. It understands context. It can draw upon a lot of memories from a lot of various sources. It can draw upon a whole set of inputs and then put that all together to reach some sort of conclusion and decision. And this is the stage that freaks people out a little bit because we simply don't know what's going to happen when we get there. And by the way, if you hear terms such as passing the Turing test or things like that, this is what they're talking about. And part of the reason that freaks people out has to do with the stage that comes after that, which is artificial superintelligence. You can imagine if you can replicate human brain and connect it to other replicated human brains, and then connect all of those and that network of brains into the internet, such that they can consume all the knowledge and information that is out there. You now have in effect created an all-knowing being or an omnipotent agent. And take your pick, Terminator, Westworld. The part that freaks people out is that we simply don't know how that machine is going to use that knowledge. But we're a little ways away from that right now. On the way of machine learning, it's basically, as I stated earlier, it's a common way, in fact, the most common way these days to build these artificial narrow intelligences. And it is an unprogrammed learning paradigm, meaning you don't explicitly write some code, if this happens, then do this other thing. And it's data guided, meaning the model that you create inevitably relies on a large volume of data to form itself, so to speak. And we'll look at these a little bit more details in the next slide. There are these common classes of ML algorithms that I'll briefly touch on, the first being regression. This is an example of a supervised learning algorithm. Its job is to predict some sort of outcome, numerical outcome, most commonly based on some historical value. So you can think about it as mortgage prepayment risk calculator. This is something that is super relevant to banks. In fact, I think JP Morgan Chase released this a little while in 2006, 2008. So they could calculate on an individual level what the risk of somebody prepaying their mortgage is, so they know how to balance that out. Because as you can imagine, there's a whole bunch of loss of interest income in there. Moving on, classification is another class of supervised learning algorithms. It has to do with finding the type or a kind of a given input. So that cat detection, or in a more real world example, finding pedestrians versus cars versus stop sign versus lanes in a self-driving car. It would be an example of a classification problem. Then there is clustering as a class of algorithms. This is an unsupervised learning algorithm, which means you don't necessarily guide the machine as much as you do. It's just you supplied some data and it trends in a certain direction. And it has to do with finding things that are similar to each other or finding things that stand out. So related articles is a good example of this. Or when your bank, for instance, sends you a text message saying, well, this transaction, was that you? That is an example of anomaly detection, which falls into this category. The last that is not commonly talked about has to do with dimensionality reduction. And it's mostly used to simplify the learning process. So you have, suppose you have a data with a lot of columns or a picture with a lot of noise. And the job of this algorithm is to reduce it down to its most relevant pieces in the service of some sort of ultimate learning goal. And then there's some advanced stuff that you hear, such as neural networks. There are different kinds of neural networks, like convolutional, adversarial. And essentially what they are is organizing some of these ML algorithms and some other data manipulation algorithms into a network such that the output of one of these algorithms is fed in as the input to another, and collectively with some threshold and boundary conditions, the whole network will make the prediction or make some sort of decision. And these neural networks are in the domain that is known as deep learning. So if you come across that term, this is roughly what these techniques are the things that they're talking about. So what are some of the common problems that AI can solve? So value estimation, anomaly detection that we talked about, ranking, which search result is most relevant to you, computer vision around that detection thing that I was mentioning, speech recognition. These are the class of problems that are out there. But in terms of themes that they fall into, almost invariably, these are complex problems that cannot be codified with simple if-then statements. And the reason they're complex is that it's either there are too many variations that naturally you can't just keep coding if and else and what have you for like a million times, no matter how much you pay a developer, or there are complex interrelationships between the components that influence the problem in a way that the whole network of all these relationships become too hard to manage with simple traditional program, so to speak. Or their attributes of the problem are changing in nature, and they're changing so fast that you can't necessarily write it in code. So for instance, your preferences or the types of things you're looking for, this is ever changing on a day-to-day basis, and it really doesn't fit in a traditional written program. So next, I'm going to focus on how to leverage your team, because no good product was created in a silo and by one person especially, and AI is no exception. So what you're looking at on this slide is an example of a highly specialized team. So this is what you're going to find potentially at a bigger company. At smaller ones, chances are a couple of these roles are getting played by the same person or the same at least team. But let's take a look at them. I always start with the privacy manager because they tend to come on earlier in the process outside of the product manager. Excuse me. Their job is to help you make sure what you're doing is legal, is compliant with any regulations that may apply to it, and it's also compliant with your own policies, and most importantly, it's ethical. Then there's your design team, which could be subdivided into research. These are the folks who go out there and understand what optimum user flow works best for your product. And then there's the actual UI design, so how to make it look intuitive to humans and how to make it usable and what sort of visual elements need to be present. And a good thing over there, the thing to focus on over there is the AI specific one emphasis that happens a lot of times is how do we make this not creepy? Because, as you can imagine, something that makes predictions, if it makes too good of a prediction, it can rub people the wrong way. Then you have your core data team, if you will. These are your data scientists, your data engineers, your ML engineers, and their job is pretty much to help collect the right data and right amount of data, and making sure that data, what I mean by right data is making sure that data is representative of your ultimate goal of what you're trying to achieve. There are all sorts of biases that can happen in a data. A data can have missing values. There could be attributes that are missing. And all of these are a set of decisions that your data scientists and your data engineers and your ML engineers, to an extent, will help you make in order to be successful. The job of the ML engineer is to make sure that you're selecting the right algorithm or algorithms or designing the right type of technical solution, so to speak. Then you have your software and DevOps engineers. These are the folks who weave in that model that you just created into an actual product that is used in a production environment. So they deal with, at the end of the day, that model, that prediction is still functioning in the context of a bigger piece of software, and integrating that properly is a job of your software engineer. Also, AI is a fairly new field, so it doesn't necessarily benefit from a rich set of tools and other types of bells and whistles that come with the traditional software engineering. So sometimes it is hard to productionalize it, and it takes effort just to take a model that was on a dev box into a production environment. So that would be technically a job of your either software engineer or DevOps engineer. And there are times when you need a bespoke, like totally custom-made AI algorithm. And this is where your AI researcher comes into the picture, although this is not as commonplace unless you're in some sort of very highly specialized field or you're in academia doing some sort of research. Now, with that in mind, I'd like to transition over to the product life cycle or the product cycle. And before I get into the AI specific stuff, I'd like to talk about the basic product cycle, because at the end of the day, an AI product cycle is not that different. It's just something that lays over on top of your basic product cycle. So, whenever you're developing a product, you're roughly going through these steps. You're trying to understand the business context in which that product lives. These are the goals of the business in releasing that product. Are they after revenue? Are they trying to increase engagement and retention? Are they after user acquisition? So those are the examples of a business objective. And then from there, you transition into who your customers are and what their needs are. And this is where you segment your market, select a subsegment that you want to serve, and then go really deep into understanding their needs. And once you have these two pieces in hand, then you can start hypothesizing about, okay, these are the set of problems for my user that I'm going to solve, or my customer that I'm going to solve, which then gives you a set of success metrics. And so if I succeed in solving those problems, you make a hypothesis that this needs to happen, and this normally is represented by a metric. So like if your metric is retention of users, then your daily active users will go up, as an example. Then you start producing your alternatives. So how can we go about solving this problem? And out of those alternatives, you select one or a few, and you write some code about it. And then you prepare to release it to market. This is where you are working with your marketing partners to put together a go-to-market plan around where to launch, how to launch, what sort of marketing material you need to put out there. But once you go over that, you actually do launch, then you get into a mode of monitoring your product against those success metrics and adjusting course as necessary. So how does AI change all this? Truth of the matter is it doesn't in a lot of ways. It's just that it just overlays on top of this existing product cycle. So for instance, in the case where you are understanding the business objectives, or in the case of an AI product, it's important that you understand the business constraints. AI is a very data heavy type of enterprise, so it is important that your business is ready to invest. This is both in terms of monetary readiness and also having the right set of infrastructure and set of policies to be able to successfully launch an AI-enabled product. Then you need to understand how your customers benefit from AI, because not all the times customers benefit from AI. And if there's no clear benefit, chances are that the downsides of introducing an AI type of solution will outweigh its benefits. And with that in hand, you then need to define what your success looks like. And then there's some AI specific metrics and goals that you need to set. This is where your data scientists and your data team will be of great help to you, because these are the folks who can help you measure how your model is performing. And that's what I mean by AI specific goals and metrics. So, once you start going deeper into AI, or ML in particular, you see that a model, for instance, can overfit, which means it can be really good at predicting based on the set of data that you trained it on, but that may not necessarily be representative of what can happen out in the wild. So these are this is what this step is all about. And this is where the next step is where we deviate a little bit from the previous product cycle. It's not that there's no privacy or legal review in a traditional product. It's just that in an AI product, it's extra important to take those steps. So I recommend to anyone who's starting in the field, do not do any sort of AI type of work unless you've reviewed it with your privacy folks and your legal to make sure what it is that you're doing does not violate the rights of your users, for instance. And this step is super important to happen before you do anything, even a prototype that uses real customer or user data. Suppose you go beyond that step. This is the step where you gather and groom your data. So gather is fairly self-evident, but the only thing that call out there is that more often than not, you're not gathering data from just one source. There are multiple sources that you need to gather data from, and they're not always in the in the same format. So there might be disjoints in the data, and that's roughly what I mean by groomed. So making sure all those formats match, making sure if they're missing values, you know what to do with them. Do you want to pre-fill them with some predetermined value, or do you want to just remove whatever row that is missing a certain value? So, and again, this is the part where you lean on your data scientists and your data engineers to help you out. So once you have these in hand, then you train your model. This is just a matter of feeding all the data that you collected and groomed into a training algorithm, and then having it just improve over time. And once you meet that threshold, that you set in your goals and metrics, then you're ready to release the market. Releasing an AI product to market is not that different, except you do probably another round of reviews with folks, make sure all the T's are crossed and I's dotted, and then you're ready to release. And it's the same deal that with any other product. You monitor your AI product in the wild, and then you adjust as necessary. The only thing to call out there is you also need to monitor those AI-specific metrics to make sure your model is not deteriorating in performance. So this pretty much wraps up my talk about managing your AI-related product and how your role fits into the overall picture as a PM. But the next topic that I'd like to briefly cover is what are some of the things that can go wrong that are specific to AI, and what are some of the things that we can learn from it? But before I go any further, I'd like to remind everybody that the things that I'm covering over here is no reflection about the folks and the teams and the companies that worked on these products. I'm just merely using some of the rather unfortunate cases that happened with AI to illustrate a point. And it is very critical to keep in mind that a lot of these a lot of these mistakes can happen to anybody. And it's very hard to have a bulletproof AI system. With that in mind, let's begin. So the first problem that I'd like to focus on has to do with the data-driven nature of AI, and is what I had to abbreviate into the GIGO problem over here, just to make sure that the title fits up there. And essentially what it means is that because AI is such a data-driven enterprise, you get what you put in, you get out from it what you put into it. So in other words, if you put in garbage data in, you're going to get garbage data out. Now, on the surface of it, it sounds like really simplistic not to put bad quality data in, but there are a number of reasons why that can happen. First off, is that your sample size was too small relative to the problem that you were trying to solve. So the prediction, although they fit perfectly on the training data, has nothing to do with what actually goes on in real world problems. Secondly, the data was biased or unrepresentative for some reason, not due to volume, but your data can get stratified in a way that, again, deviates from what actually happens in a real world scenario. But the more common ones, perhaps, is data starts changing in ways that you didn't anticipate, and that data is looping back in a feedback loop that retrains your model. And that's where this example that I have on the right comes into the picture. So for those of you who don't know, this is Tay. This is a AI Twitter bot that was made by Microsoft. And it was actually a very smart bot. The idea was it interacts with people on Twitter, and it tries to present a natural human-like dialogue with the world. And in the process, it also learns from the retweets or the, any sort of signal that is fed to it. Now, on the surface of it, this idea worked brilliantly, except that there is a subset of people on Twitter who are into trolling, and that's just the reality of that platform. Unfortunate reality, but reality nonetheless. So they started bombarding this bot with tweets that were mean, racist, homophobic, otherwise a lot of negative connotations. And the bot started learning from it, and before you know it, it evolved into the same racist, unkind, you know, horrible creature that was spinning out of control and had to be shut down. So what are the ways you can prevent this? Again, by no means this is an exhaustive list, and by no means I'm saying like do these 10 easy steps and you'll be golden. But some of the things you can do is, first off, make sure you lean in on your data scientist a lot to try to catch these things up front. Second, see if you can create quality gates ahead of any feedback loop back into your model. So for instance, if you have offline training models, if possible, where data is fed in back into your training set, you know, overnight or not in real time, you know, then that gives you the opportunity to train it in a sandbox environment and see what comes out of it, and catch some of these errors early on. If you can't, if you have to train in real time, try to put some at least alerts and gates and controls in the interim to at least alert you or perhaps even delay a little bit if certain quality metrics start deteriorating. Again, not bulletproof, but potentially a way to catch some of these error cases. I reemphasize again, this is not a reflection on Microsoft or the team that worked on this. This is just to illustrate that a company the size of Microsoft, investing billions of dollars into these technologies, if they can get it wrong, or if they can get it wrong sometimes, so can you. And you know, you just got to be humble and learn from it and move forward, which is what they did. The second example that I'm going to give has to do with the narrow nature of the current AI that we have at hand. AI systems will optimize for what you ask of them. They are unaware of a context, and they're very good at you know, optimizing that narrow scope that you define for them. And outside of that, they're unaware of the bigger context. And the horrible thing about AI is that its failures, its most egregious failures, are oftentimes silent, and they won't show themselves until and unless somebody or some group points it out to you. The picture that you are seeing on the left is of Rebecca. She's unfortunately no longer with us. This is something that happened in 2014, which is where I believe Facebook released their year in review product. And you know, the algorithm that they put together would attempt to pick bits and pieces and highlights of your year to compile a delightful little snapshot of your year. And here's what your year was like. It turns out that algorithm was queuing a lot off of engagement signals and a variety of signals that, you know, without the broader context of what that engagement might mean. So we inadvertently, and when I say we, at the time I wasn't there, so I didn't have to do with this product particularly, but you know, that product started showing Eric, Rebecca's father, pictures of his daughter who just passed away, and we inadvertently started causing him a great degree of pain and suffering, which he was kind enough to write a blog about, you know, and inform us and the public about the situation. And again, just to set some context here, this is no reflection of the folks who worked on this product. I don't think anybody, and in fact, I'm sure nobody sat in their office and said how we're going to hurt a grieving father's feelings. This is a complex space, and then sometimes the second or third order consequences of some of the decisions that you're making ends up, you know, making your system and behave in ways that does not fit the context. And that kind of brings me to my potential solutions over here. And again, by no means these are solutions. These are merely things that you can do. These are things that you can do your best to consider, which is try to consider the edge cases and normal, non-normal operating environments. And then try to be aware of second and third order effects of what it is that you're releasing. And, when, not if, when you mess up, apologize, empathize, learn from the thing that happened and adjust course. And that's exactly what Facebook did in 2014. The last bit that I want to talk about has to do with privacy, law, and ethics of AI. So again, going back to that narrow scope of AI, you have to consider again that AI systems are not aware of the ethical constraints that are to be placed on them. They just, then they also use the data that you will supply to them. And they'll make the decisions and they're optimized for the values that you're trying to optimize for. So it is up to you to consider the ethical consequences of what it is that you're about to release. It is up to you to have written principles and make sure you abide by them. And you won't be able to get all of this right, and you won't know all of this. There will be unknown unknowns, which is important that you listen for expert feedback. There are folks who are dedicating their lives to ethics of AI. So it's important that you leverage them, listen to them, and just be aware of the bystander effect. It is easy to say, hey, this one's not my job. It's not my call to make. Just try to release, I'm just trying to release a product here. Reality of it is that it is your job. Considering some of these privacy aspects of AI is your job. Considering the ethical aspects of what you're releasing is your job. And there's no clear-cut answer, which is why I go back to having principles and at least knowing, having those principles inform the direction that your product is going in. There are many examples that I can pick from over here, but some of them just on the screen for you to see. Faceception was attempting to use facial features detected and have AI detect someone's IQ or some other attributes about them. This is what we showed a little bit earlier about China's social coherence scoring system, so social credit system. That's an example of something that might be ethically suspect. And finally, it's not just outside of the United States that these things can happen. So this article from MIT Technology Review was saying something to the effect that AI was being used to deploy police forces across different neighborhoods, and that was resulting in people getting wrongfully incarcerated. So, and to be clear on this one, I'm not here to judge one way or the other. I'm not saying that I have some sort of golden key to what's ethical in the way of AI versus not. What I'm here to do is to caution that you, at the very least, need to consider these ethical questions as it pertains to AI. So I'd like to wrap this up with a couple of final thoughts, so to speak. So my first one is that don't think AI is some sort of magical ingredient that you sprinkle on your product and hey presto, you have something fancy and ready to go. You still need to put focus and attention and work into other areas of product. This is design, this is functionality, this is performance. So fundamentals, focusing on those as well, try to focus on those and then get those right as well. Secondly, real world AI requires a lot of data. It also, on top of this, requires a well-set infrastructure, both in terms of policy and the actual technological infrastructure to do it. And you got to be sure that your business is ready to invest and it's the right time to invest. And next, real world AI is a team sport. So you got to make sure that you're leveraging your team right. You got to make sure that you build the rapport with your team such that you can seek their advice and help and guidance, and you got to take it. Finally, privacy is an integral part of your AI product, so take it seriously. And ethics is also part of your product. So be sure to have principles, write them down, and start from those principles. Thank you so much for taking the time to listen to me today. I included on this slide a few additional resources. These are both like other talks. The first one, for instance, by a good colleague of mine, who's a PM at Google, talking about machine learning and AI in more technical depth, which I highly recommend. It's a product school talk, as always, so you know it's great. And the rest of it are some additional reading that might help you. Thanks again for taking the time to listen, and I hope you enjoy the rest of your day.